Well, we should go ahead and get started. we can't put things off too long. My name is John Goff. I am one of the nominators of the 3 awardees for this session. This is U22B, New Generation of Scientists. These are some of our up-and-coming young scientists, and I'm really excited to hear your talks. We have Andrew Green from the University of KwaZulu-Natal, South Africa. He is getting the Africa Award for Research Excellence in Ocean Science. We have Andrew Akala here, University of Lagos, the Africa Award for Research Excellence in Space Science. And we have Francesca Landes from Lamont Doherty Earth Observatory for the Science Solutions Award. So we'll start off with Andy Green. Andy was cited for his excellence in research into understanding coastal response to sea level change on the African continent, and for developing research and teaching capabilities in South African marine geosciences. Andy, welcome.
Can everybody hear me all right? It's quite a big hall with not so many people. Well, thank you very much, John. And firstly, I'd like to thank the AGU for allowing me the opportunity to be here, and of course to talk to you about some of the challenges that we're facing in marine geology, where we come from in terms of the past, where we are at present, and where we're going to in terms of our future, not only in South Africa, but across the African continent. So my name's Andy Green. As John says, I'm from the University of KwaZulu-Natal, which is on the east coast of South Africa, and I'm going to take you for a little walk. So most of you will know Africa, or South Africa at least, by the town of Cape Town, which is on the west coast. There are, in fact, other cities. So I like to think of the coast as divided into 2, the left coast and then the right coast. So I'm from the right coast, which is the coast of KwaZulu-Natal. I'm from the city of Durban. Durban is well known to most people in South Africa as the warmest place to be. So if you plan on visiting, please make sure to drop by. To give you some context to marine geology in South Africa, so to set the scene, marine geology was thriving throughout the 1970s through to the early 1990s. And most of this was spearheaded by the University of Cape Town in conjunction with governmental research organizations, which was the Council for Scientific and Industrial Research, and the Council for Geoscience, which was then known as the Geological Survey of South Africa. A number of landmark papers were produced, and basically these had a broad scale all the way from deep water work through to shelf work, understanding both shelf processes all the way through to understanding continental breakup mechanisms around the southern oceans, the Southwest Indian Ocean in particular. So this then spread through to the east coast, so to where I'm from, to my university, which was then known as the University of Natal. So through to the early 2000s, here the focus was more so on coastal and estuarine work, and there was some shelf studies associated with this. Again, there was a unit formed at the university with the main governmental funding organizations. And unfortunately, commercialization of these governmental entities basically caused a crash or an implosion in research activity in marine geosciences. So rather than pursue research activities, these were commercialized and looked for commercial work throughout the African sector. And ultimately, these units then closed. So there's no academic units associated anymore, really, primarily with marine geology across southern Africa. So if we set the scene now in terms of what actually is happening in Africa, there's only really 4 main countries that have interests in marine geoscience. And so I'm classing this as research, supervision, and of course some sort of curricular development according to marine geology. So Nigeria has 2 agencies associated, both of which deal mostly with coastal changes, coastal environments, and geochemistry of coastal environments. Kenya and Tanzania have 2 research institutions that list on the websites as marine geology being a focus, but the outputs are uncertain at present. The University of Cape Town, which was once the leader, I would say, in African marine geology, is ultimately closed for business, not as a research institution, but more so for their studies in marine geology. So the person who was associated with that has since retired, and really this just leaves our institution and myself as the head of that marine unit to be the fundamental body involved with training and research in Africa. So this is a broad spread of where we're working. So blue stars are collaboration and the red stars are research projects. We can see A lot of research clustered around Southern Africa, which is a good thing, but what I find perhaps really healthy is the fact that it's not just people looking inwards from other countries and coming into South Africa, but also our expertise coming out of South Africa and into other countries. So we are expanding research projects around the world, which I think is a healthy thing. Obviously, also the collaboration here plays a good role in terms of a healthy, vibrant research program. So if we look at our 10-year challenge, so where we are, and I'm going to focus here mostly on the Southwest Indian Ocean shelf, so where we come from and where we're going to. So ultimately, these very, very sparse lines are the major seismic coverage of our shelf. A little blob over here, you can't really see it. That's the majority of multi-beam that was collected, multi-beam bathymetry to understand our seafloor. That was collected actually for my doctoral studies, which was finished in 2009. And that was the very first multi-beam bathymetry ever collected for academic concerns in South Africa. So very far behind other countries around the world. Where we are today, I think, is quite encouraging. So from my unit, we have a much better coverage in terms of the continental shelf, lots of multi-beam, lots of high-resolution seismics, and we've gone about this in a systematic way of mapping areas of interest, expanding those maps, ultimately to understand the geomorphology of the continental shelf, its structure, and the evolutionary characteristics. So because we have time constraints, I'm going to discuss really just one current research passion and thrust. Because it's a small unit and there's only one person really associated with this, we have a big draw on a number of different research projects, but I'd rather focus on one that's, I think, close to my heart and has a great deal of societal relevance, which is looking at submerged shorelines and coastal deposits that are preserved as relict features on continental shelves. So we need to ask ourselves several questions then. What can these reveal about paleo sea levels? So paleo sea levels are important to understand. We need to have a glimpse in the past to know where we're going in the future. Coastal deposits and submerged shorelines relate and associate to sea level. So where we find these things submerged, we can actually relate that to a sea level context, which is important. Secondly, in looking at submerged shorelines, we can look at how these things have behaved over time in the context of sea level rise. So sea level being the predominant forcer of coastal change, usually also associated with some sediment supply, and also other factors, so things such as localized context, bedrock perhaps, or sediment supply, and how this can either ameliorate or exacerbate changes caused by rising sea levels. The reason we're so concerned about these sea levels, obviously, is because in changing climates and rising sea levels, these are threatening coastal habitats and, of course, coastal areas of urbanization. So this brings us to probably the most important point, and the point I think that would make a good discussion, hopefully later over a beer or two, would be how can we then use this knowledge to better inform coastal planning? So how can we use this as a means to better understand and plan for expected changes in rising sea level associated with climates in Southern Africa? So I'm going to show you guys now a few individual shorelines that I've actually picked out from our mapping. Most of these occur at about 60 meters in depth, and I'm going to take you to Richards Bay, quite a heavily industrialized port city on the east coast of South Africa, pretty much halfway between the southern point here and the Mozambican border to the north. So if we look at 60 meters depth, what we find here are a series of preserved Holocene age beaches that are configured in log spiral bays with a multiple series of inlets incised into these. So this is important in seeing these because if we look at this in terms of context, we place the current coastline over this as an overlay. They are remarkable in terms of the overlap in size and scale between them. So what this is pointing at is pointing to a very well-developed equilibrium shoreline that has been produced at a 60-meter depth. We can see this as well within seismic data that we've collected across the shelf. And this is going to give us a clue, the idea that sea level must have been occupying that area at about 60 meters. If we go right down now to the southeastmost point of South Africa, which is down here, the Port Elizabeth and East London part of the coast, again at 60 meters depth, we find a series of similar log spiral bays, all Holocene in age. Within these, we have embayments that have been cut. There are cliff lines that have been cut in as well, so denoting erosion as opposed to deposition. And we have parabolic dunes that have been preserved on the seafloor. All of these again point to some occupation of the sea level at that area or at that time. If we overlay them again with the contemporary coastal landforms, we can see these things very similar in terms of their size and scale. If we look at Durban now, which is my hometown, it's the town I live in, just south of the main port, which is the largest port in Africa, at a 60-meter depth again, we find very similar features. Here we have drumstick barriers that are preserved. So drumstick barriers are relatively unusual landforms, quite well known from the US continental margins. Nothing that we find in contemporary times here. These have been yet to be sampled and yet to be dated. But if we look at this again, it bears quite a striking similarity to drumstick barrier islands that are developed along the North Carolina coast of the US East Coast. If we take depths that are slightly shallower, so if we look offshore the largest river on the east coast of South Africa, from depths of 40 to 35 meters, we find here, interestingly, a drowned series of Holocene age deltas. So we have deltaic bodies of sediment that are almost entirely preserved on the seafloor, which is unusual considering this is an area with extremely aggressive wave activity. The specific wave heights for the coast here average 2 meters throughout the year. So this is an area where sand is usually dispersed as opposed to preserved. So we have these drowned deltaic bodies, and even better, we find that there are multiple phases of backstepping recorded within these bodies. So here's one delta lobe here, there's a secondary one overlying that. What that's alluding to is multiple phases of rapid rise in sea level, causing the delta to step back and then reprograde out. This is interesting because we have no data for these depths and for these multiple rises in sea level in southern Africa, or actually in the southern hemisphere, to be precise. So this is going to be a useful bit of information. We'll talk about that now. Again, if we go now to an area called LOL Shoal, so this is one of the principal scuba diving holidays for people that come in as tourists. It's a really nice place to go scuba diving. At depths of about 40 to 35 meters, we find again, and this is really quite spectacular, a perfect preserved Holocene drumstick barrier again. And this is fronted here by these unusual arcuate cusps, and in the back here by arcuate spits. Really what this shows is we've got a big barrier island developed here. This would have been a coast, and in front of it, we'd have probably had a lagoon. It's not really sure. We'd need to map this better, but a lagoon out here in the front. So really we've had, again, a situation where sea level's now been sitting at about these depths. So what really does this mean? So how can these observations provide constraints and things? So this is the sea level curve that we've produced through a series of dating of cores that we've collected over time. This is allowing us to provide constraints in a number of things. Firstly, the timing of sea level when sea level rises extremely slowly. To produce all of these landforms, you have to have stability in sea level, and this has to be matched with an equilibrium between wave energy as well as sediment supply. In looking at where these things develop on the continental shelves, we can point to areas where we should be expecting relatively slowly rising sea levels. Dating of these allows us to constrain this part of the sea level curve better. As you can see, part of this is not very well constrained at all. If we take it a step further, this also allows us to understand the timing and the magnitude of the impacts of meltwater pulses. So a meltwater pulse should be concerning all of us who live in coastal environments, namely because these relate to catastrophic collapsing of the ice sheets and rapid rising of sea levels. So these rapid rises of sea levels are what we evoke in our understanding of how these shoreline deposits have been left behind. A very rapid rise in sea level will ultimately allow these to be preserved as opposed to eroded by migration of waves and surf zones across the continental shelf. This really gives us then a glimpse into how coastlines respond to these catastrophic ice sheet collapses. And we should all be concerned. If anyone here has read the latest IPCC reports, sea level is definitely rising, it's going to continue to rise, and it's going to continue to increase in the rate at which it rises. So how coastlines respond to that? We're looking at analogs ultimately sitting on the continental shelf. Will this coastline, and this is the coast of Durban, will it adjust in equilibrium with rising sea levels, or will it be left behind? And the data suggests it will be left behind. This needs to be fed to planners to create adequate setback lines and coastal planning initiatives that are going to adequately address these coastal hazards and impending threats. And lastly, this is useful in terms of constraining post-glacial sea levels from far-field sites. Very little is known of far-field areas. That means areas far away from the melting of ice caps, areas that have no actual glacial activity. Most of this is modeled. Most of this is a geophysical model that is produced of how the ocean behaves during deglaciations. This provides constraint, real-world data to feed that model, to better constrain it. Otherwise, a model is just a model. So data that can then be fed in and allow us a better understanding of how the global changes in ice sheet volume and seawater volume have changed. If we take this a step across now into the west coast of southern Africa, at depths of 60 to 10 meters, we see, again, really interesting shorelines developed, multiple interesting seafloor features that relate to a similar sea level history that I've described for you now for the east coast of South Africa. And this is the project that's run in conjunction with Anglo-American and NAMDEB, which is the Namibian aspect of De Beers, consolidated. It's in this area here, this little red box that we're focusing. This is an area that's called the Sperrgebiet. I'm not sure if there's any Germans in the audience, but I think I got it right. So the Sperrgebiet translates to the forbidden zone, and it's forbidden ultimately because of the diamondiferous materials here. This area is host to the highest quality gemstones found on Earth. So obviously the mining concerns there are very interested in focusing there, and so access is strongly restricted. And I like to think it's the forbidden zone also because this is not an area that is amenable to coastal and marine surveying. So here we have the coast. You can see the scale of the wave breaking in the background. This is one of the most energetic coastlines on Earth. And this is not an area where you launch out in a nice fancy research vessel from a harbor. This is Africa. We launch from the coast in a little ski boat, and we basically go out and we do our marine surveying out here. To give you guys context, out of the 365 days in a year, 14 days are workable in terms of seagoing conditions. So collecting data out there is an extremely challenging and difficult undertaking. Nevertheless, we've collected a lot of data. We've covered this area now with high-resolution multi-beam bathymetry and lots and lots and lots of high-resolution seismics. And what we find here is that the shorelines that we see on the east coast are reflected somewhat, and these mark the position of diamondiferous deposits. So not only has sea level acted to show us things about how coasts respond or how sea levels have changed over time, these shorelines show us that, but they also give us areas where we know diamonds are going to be. So all of these irregular little humps that you can see on the seismic line are ultimately barrier beaches and barrier spits that have been preserved on the seafloor. And we know these are diamondiferous, we've cored them. And we can relate these to the onshore deposits. So in these areas, we have these beautiful raised gravel beaches and gravel spits that are extremely diamondiferous. As I said, host to extremely high quality gemstones. In the offshore record, we can core these. In this core here, you can see the same sort of gravelly material. And it's very likely that you will be actually looking through one of these cores and 1 or 2 raw diamonds or rough diamonds will be in there. To get access to these cores, you need to have police clearance, you're fingerprinted, you need to have no criminal record. It's quite a serious business. So where to from here? Well, obviously, we've got all of these research projects going, and we hope to grow. So this is the current context to what we're looking at in terms of postgraduate numbers, just for myself. So that's, I think, 8 MSc students by research. We don't do coursework MSc, and we have 5 PhD students. So this is a lot to undertake just for one person. I'm the principal supervisor for all of them. I collect the data. I act as the technician. I act as the grant writer, the proposal writer, the paper writer, the reviewer, etc. So obviously this is not a real sustainable situation. As we are here, I think we're sitting at a tipping point in terms of sustainability. So we need to grow in staff. And not only that, we need to grow in collaborators. There are many instances here where, sure, you can be a jack of all trades, but there are certain aspects that you require expert knowledge, and that needs to be brought in from collaboration. So that's things such as modeling. How do we model how sea level is affecting coastlines? We have a great analog, and someone needs to throw some mathematics at this to be able to create a good model that we can then hand over to marine and spatial planners or town planners, etc. So collaboration, I think, is key. In so doing, I would hope that we would grow our unit in terms of both African and international student cohort. So currently we have a few international students studying towards their doctorates, but ultimately I'd like this to be an area where people from across Africa would come to study and then to take those tools that they've learned and go back to their countries and invest it. That's the way in which I see African marine geoscience growing. So ultimately to become a center of excellence in African marine geology and have this in association with our African partners. And this is where you come in. Obviously, we would like you to come and work in South Africa. We would like you to bring your expertise. We would like you to bounce ideas off, to supervise students, to review papers, etc. So what to expect? Well, Africa is not a place for sissies. Unfortunately, it's a dangerous place. So this is an area here where we've done a lot of nearshore surveying and diving. And you can see here, this is Africa's second most dangerous creature. That's the hippopotamus, second only to the mosquito, if we discount humans. And here we have it having a little swim in the ocean. So, this is not an area where you don't mess around, let's be honest. Likewise, in many of the areas we're working in coastal water bodies and estuarine systems, this is a common thing, crocodiles. So here we are, this is after a nice afternoon barbecue. We typically go out and go fishing for crocs. No, this is actually just merely a sampling program in the coastal water bodies. They're pollutant sinks, and a lot of those pollutants, like ultimately pesticides, end up in the tissue fats of crocodiles. They're excellent in terms of monitoring that. So here's a friend of mine who's actually been involved in that. This is kind of what we do in many of the instances. So we don't have great research vessels or anything. So we usually use these little rubber ducks. And most people in terms of seismic surveying are used to long kilometer streamers and big air guns and those sorts of things. No, here we have our famed African seismic array, one boat towing another boat towing the seismic equipment because we couldn't get this boat to work, which we'll always make a plan. Here we are sitting in one of the distributaries coming into a little delta. This is a famous place for crocodiles, and here I am standing knee-deep in mud, and you can actually see a series of hippo footprints in the background. So these are quite wild areas. And to finish off, we all desire our nature papers. It's something I think all scientists ultimately covet here and there. I'm not sure when mine's coming. If it will, I'd be very happy. But I think this is probably the best shot that I have for a nature paper. So for those of you that aren't marine geologists or geophysicists, these unusual features in this gray squiggle are basically what we call seismic diffractions. You see these things when you go over a hard object or a fault or something on the seafloor. We went over this object and I was very excited about this. I thought, I've discovered a new fault. And instead, I think I was the first to discover the seismic fasces for Hippopotamus amphibius. So we actually drove these tiny little research vessels in about 3 meters of water over a fairly large and aggressive hippopotamus. That was one of the more interesting experiences of my life. I'm hoping that this might come out in nature. So if there's anyone here on the editorial board or a reviewer, perhaps, let's talk. We'll go and have a beer later if you'd like. And I think that brings it to a conclusion. There's just a few people I'd like to thank. So the AGU again for the award, and I think an initiative for putting Africa in the spotlight. It's important. There's so much work to be done, much to do, and with the help of others, I think we can go a long way. And it's the help in terms of a mutual help. Obviously, to my nominator, John Goff. John was extremely kind. In 2006, John and I wrote, I think, my first paper ever published in an international journal. He taught me all the tricks, and I'll always be forever grateful. To my supporters, who supported my nomination, Edward Anthony, Andrew Cooper, Joe Kelly, and Berg Fleming. Appreciate their kind words. I think then I'll save my wife till last, but the various postgrad students and colleagues who have helped to produce the good data sets with which we worked on, I'm really grateful. And lastly, to my wife, I'm sad she can't be here. We couldn't afford the extra $100 and something to bring someone in. But she's been on many field trips, mostly coerced and oftentimes lied to under the auspices of just having a nice holiday. So she's no stranger to mud, tick bites, fleas, those sorts of things. But without her, none of this would be possible. And thank you all for your attention.
Any questions for Andrew?
Lillian?
Have there been any policy changes in South Africa to prepare for like sea level rise or anything moving forward, or is it even like a topic on the agenda?
It's a really interesting question. So a lot of how we see things in terms of urban policy and local policy is driven almost entirely by civil engineering, of which they don't take the fatalistic approach that we may do as geologists. Instead, they take the approach that you can defend it. So you can put down gabions, you can build groins and piers. And really, we know now that these are failed measures. We know what's coming. We know that we're expecting rising sea levels, increases in storms. Policy hasn't yet addressed that, and that's the big concern. So there's setback lines, but those setback lines are wholly inadequate, in my opinion, looking at just having a look at the data that we've gone through and looking at what's predicted. So it's frightening. And it's the hope that the very small contingent of marine geology, which is ultimately drowned by things like biology and oceanography, hopefully will make enough of a noise in the future. And this award, I think, goes a long way to that, for people to actually listen, the policymakers.
One more question, quickly.
Do you have
So no idea in terms of that, so the decoupling of the ice and then the ultimate eventual rise of sea level, we've just only managed to constrain the time of that rising sea level. So I think a lot of the guys that do the cryosphere modeling are the ones that would probably best be able to answer that.
All right, thank you.
Thank you, John.
Great.
I think I've got everything.
Okay, from one Andrew to the next. Andrew Akala is the award winner for the Africa Award for Research Excellence in Space Science. Why don't you come on up and give your presentation?
Yeah, thank you, John. Good morning to my audience. Okay. So thank you. I'm here to present some parts of the work that we are doing at University of Lagos with my team, my Ph.D. students, and master students as well. Just in a way of appreciation, maybe to start with, I really want to thank GU leadership and the award selection committee and the honor committee for this prestigious award of recognition that's bestowed on me. My special appreciation again to Satime Basu, late, and Sunada Basu, the initiation of this award. I first met that couple while I was on Fulbright at Boston College, and the relationship, even to date, so much really gave me a sort of inspiration to do better science. My nomination was actually made by Charles Carrano, and the nomination was graciously supported by eminent scholars in the area of space science, Sandro Rosella, Jacob Adeni, and Oliver Obru, the president of African Geophysical Society, under whom I'm serving as General Secretary. Carrano was actually my second advisor while I was on Fulbright, where Pat Doherty was my advisor on the Fulbright program. Rosella currently is my advisor on ICTP fellowship program. My core area of research as of date is now understanding the quiet and storm time dynamics of African equatorial ionization anomaly. Equatorial ionization anomaly is a strip band within plus or minus 15 of the magnetic equator. It's a region that's high with high dynamics and complex electrodynamics in the ionosphere. The outline just want to follow as shown on that slide. In a way of introduction, this strip within Africa is quite dynamic, and research over the years have actually shown that dynamics was quite high in Africa as compared maybe to South America section or the Asia sector. So despite the fact that the dynamics was quite high, the quantum of research that we have in area in Africa was quite low. And that, in a way, may really hinder the progress that we want to make, even on a global scale, really, as far as understanding of the dynamics of the equatorial ionosphere is concerned. As of today, even within the Africa sector, the awareness is quite low, particularly within the government circles in African nations. Part of this work is a way that at the end of the day we'll be able to develop work that will be able to go a long way in really creating awareness as in area of space weather implication to systems like GNSS and other man-made systems that depend on ionospheric radio propagation. Like I said earlier, paradoxically, the work that is done in Africa is quite low, and much work is needed to be done in that area. But if we can harness full benefit of GNSS and the impact that space weather may have on them, and to create a clear understanding to build systems that are more robust in the future, the better for us, even as a people. I may not want to go over this, but maybe briefly just to mention that we know that in every 11 years, the activity of the sun really go very high every 11 years. And because of that, it's expected that at the peak of it, which was 2014 and around 2014, that's when we have the maximum of solar activity. But as we are now, it's actually declining, and we are going to the minimum phase of the solar cycle. So I actually have about 3 studies that I will just mention for briefly. This is actually quiet time characterization of African EIA. Like I said, the EIA that I mentioned is just a band that's about plus or minus 50 degrees of the magnetic equator. That's actually just about the processing of data. Let me just go briefly about this result. This is just a sample result, really, of a particular year, 2013, which actually is solar maximum. For each month of that very particular year, we can see the dynamics was actually high within this season, which actually the equinox season of March, and around September equinox as well. And very, very low around June and July, which is actually always the trend, really. But we see that we have always 2 peaks, which is called the crest of the anomaly, is well formed around March and April, and around September, around October and November as well. And again, we went further again to now begin to see the peak, the formation of this crest that we said. We're trying to partition the slice the data into 3 hourly data to really see. But from the result, we are able to see that the hour of 13 of 1500 to 1700, that's when the peak is well formed in most of the months that we analyzed. Like I said, these are just the samples that are just data, which case study really to show. On that, the summary of finding is based on this, just to show that within 600 hours to 1300 hours, the peak, the electron, the total electron content, high dynamic at 1300 and low dynamics at 600 hours. And again, to say that the peak was well formed around plus 18 degrees, which normally is about 15, like I said, but in some cases we saw it to about 18, which are showing that around solar maximum of 2014 and 2015 specifically. Tech and the location of the crest increased with solar activity. That's expected, really. What is somewhat distinct about here for us is to know that the EIA profile became very distinct around 15 to 1700, really, based on the 3-hourly slicing of the data. And again, to know that the one that is forming first is actually within the northern hemisphere, and the southern hemisphere will follow later. I mean, the southern hemisphere crest is the one that formed first around 600 to 800 hours. And it's again the one to decay first, around 2100 to 2300. We have what we look at again, the station to trough ratio. It's just trying to look at the crest data within measurement at the crest and measurement at the trough, and just trying to look at the ratio and have a comparison. And we saw that is actually a strong index for us to measure the fountain effect, which is always a very important phenomenon for us in space science. This area of just storm time characterization, the other one is one I just look at now, is about quiet time, but this storm time, I mean the geomagnetic storm activity really, and their impacts on the dynamics of the ionosphere. So in area of storm time characterization, we're just trying to look at over solar cycle 24. The current solar cycle where we are is solar cycle 24, and starts around 2009, and it's going to end around 2019, where we are now, which is because it's coming to the minimum. But in that, we use data really, intermagnetic field data, and comparing it, looking at ICME transients. ICME is actually the coronal mass ejection, but within the interplanetary zone. So in doing that, we look at it as a factor, it's a causal mechanism to geomagnetic storm, and other transients, again, is CIR, which is co-radiation interaction region. But for this, ICM transient was actually the major causal factor of all the magnetic storms that we look at. Magnetic storms is actually the major causer of space weather effect. So in area of CIR, like I mentioned, and the diagnostic criteria for us to know, to be able to say that the causer of geomagnetic storm is either CIR or ICME, that's why we're trying to explain these diagnostic tools here. But looking at the whole data, about 21 geomagnetic storms that we look at intense scale. When we look at all of them were caused by ICM transients. Virtually all of them, except 2, that was caused by CIR. Summary of finding, just based on what I've said earlier, that all of the storm, virtually all, were caused by ICM transients. On the ICM transient, we have sheet fields, we have magnetic cloud, we have combination of sheet fields and magnetic cloud. But CIR is another component that can cause geomagnetic storm. Another study, again, is looking at maybe the impact of the ocean on even the ionosphere. So we're trying to look at data on around the oceans and compare that data with dynamics of the ionosphere at that's a particular period of the year that of data that was considered. We can see in the area of Pacific Ocean, the area of Atlantic Ocean, Indian Ocean, then the eastern side again of Pacific Ocean. So we're trying to use all these as methods. Let me not go to that because of time. But it was obvious for us that all these, the dynamics of the irregularity was high within the Pacific. I mean, all the pointers showing is within Pacific Ocean. We have Atlantic Ocean around here, then the eastern part of Pacific Ocean. So it was obvious that the dynamics of this regularity was high within the Pacific Ocean. And we're trying to look at what's happening within the ocean surface at that point, maybe the temperature, the sea surface temperature. And we're trying to have a comparison with what we have done and to see that the sea surface temperature actually was low at this particular point, and the high dynamics we saw around that particular time. So in a way, there's a connection between the ocean and the dynamics of the ionosphere. That's what we actually use to bring out, really. In summary, geomagnetic storm cause tech enhancement within the Pacific Ocean, and the result has actually shown that. Another study that we look at again comprehensively is now using the geomagnetic storm we're trying to use the geomagnetic storm to compare this data, just have a sample data here. That when we have geomagnetic storm, that when we have the depression in this DST. And that depression really have impacts on the EIA structure that we saw. We have tried to look at about 5 days before the storm main phase and 5 days after, and a day with that red dashed line really signifying the main phase of the storm. Because this storm actually occurred at the night local time within the region under consideration, within this region of the EIA, because it was a nighttime effect at that point in time, then it caused a sort of equatorward collapse of that structure as opposed to expansion that we're supposed to see, really, assuming it occurred during the day. And the main cause of that is actually about what we call a prompt penetration electric fields that are actually on the reverse when it's nighttime hour. So the summary of finding actually was based on the time, because we're trying to now consider our findings based on the time of occurrence of the storm. The storm that happened during the day and the one that happened during nighttime. All the ones that happened during the day actually cause expansion based on the PPEF, pump penetration electric field, and all the ones that happened in the night cause equatorward collapse based on the reversal of the prompt penetration electric field. Again, the causa, when we look at the causa again and the responses on the EIA, we're trying to look at it, equatorward collapse or expansion. we saw that all of them that will come during the day, it's only CIR causa that's causing equatorwards collapse of the EIA structure. This is telling us again that this CIR is less joint effective compared to joint effectiveness of the other causa mechanisms. So, like I explained earlier, just about attributable factors really to physical processes concerned, which is actually pump penetration electric feed, PPEF. So, in conclusion, it's still based on what I have said earlier, the time and all of this actually explained within even the summary of finding earlier. I may not be able to go to that because I still have some other things I want to say. So based on the future plan really, now, which is what I just want to run through, this award is indeed the clarion call to higher service for me. As for me, to now begin to work more, to really see how I can expand my research team is what this award is actually the signal that this award has actually sent to me. And in doing that, we are going to be needing people here, collaboration, further collaboration, and how I can work with people to team with people. As for me, personally, I have about 10 Ph.D. students, really, but supervising all of them could be challenging, really. So calling on people, asking for support is actually something that is very, very important, and that's what I'm actually requesting for. So, as for us in Department of Physics and the Institute of Maritime Studies, which is under our university, where I am highly involved, so we're trying to use all these space weather effects and expand collaboration with other people there, but then international collaboration is still very sacrosanct to us, and we are actually requesting for that. Like I said, it's actually just, their pictures are not really here. These are my PhD students, really, and these are the stages where they are actually in the work. And in our research team, we're trying to give a condition that before a student can graduate, really, publication in AGU journal is very, very sacrosanct to us, really. It's either they publish in JGR or they publish in Space Weather or any of AGU journals. So that's condition that I've actually placed down for them. And we can see the first one that graduated last year published about 3 papers, really, in high index journal, which AGU journals, Space Weather, and some other journals, really, Space Weather and ASR. Others, they have submitted papers, really, but actually, they've been moving up and down by reviewers, and the process, about 2 or 3 of them, the process is still ongoing, and in fact, about 2 of them, they've been on the paper for about a year, 6 months, or thereabouts. So, and they're still working on the paper back and forth, really, based on reviewer. And I am personally having a challenge, really, because administrative functions is actually taking my time. My managerial functions within the university. As I once last year, about 2 years ago, I was sub-dean of faculty, and currently I'm a deputy director. So, administrative work is actually taking off my time, really, having challenge to do supervision, really, to do a thorough job that I need to do. Although we are dancing around that, because the first one that I graduated is actually assisting me to look at the work of other students that follow. So, these are just the other requests, really. Like I said, collaborations is actually what we are calling for. But it's very sacrosanct to me to mention that University of Lagos, we are properly placed, and we are calling for maybe hosting of international events, really, because as far as Nigeria as a nation is concerned, we are one of the best universities in terms of facility. In fact, without any form of exaggeration, we are the best in ICT facility in Nigerian universities. So in area of having international events, we are very open, and we are calling for support that may come from AGU as far as that is concerned. And again, maybe in a way of my personal recommendation, I really want to recommend that as international scientists, we may have to be looking at open science. What I mean with that, data sharing and open data and open resources in every aspect should be what we are going to be looking at. In fact, open science, for me, is a public good. And if we can do that, really having open science, then we're going to have public benefit of that, even as scientists or even as people. And again, to really see that any science that we are doing, because that's where I'm driving to, even as a person or with my team, that everything that we are doing is having a form of sociology and economics in the science that we are doing, even for national development and for global development. In the way of acknowledgement, let me just acknowledge this organization that have actually sponsored my research in the past. Principal among them, actually my university, really, most of my research presentation outside attending conferences, my university have so much be very supportive about that. And Fulbright Scholarship Board, really, in 2010, when I came for Fulbright, that Fulbright scholarship actually changed my focus on the horizon about research when I had my Fulbright with Boston College, Boston College in 2010. Then ICTP, International Center for Theoretical Physics, really, I'm a fellowship of that, so it was a place that I go virtually every year, and because of that, that's actually changed my focus, really, in research. You know that's United Nations, the Office of Outer Space Affairs, they've actually supported my work at many times. COSPA, AGU, which is part of what we are doing now, because AGU graciously have been supporting even African scientists, really, that the publication fees actually were considered and waivers given at times. So it's actually support for me and for African scientists. I am indebted to my students, really, past students and present students. Present one Ph.D. student, master student, they actually part of my team, and they be helping me, even despite the fact that I'll be so busy, like I said, with other administrative functions. I thank my wife sincerely. We're supposed to be here together, but for some stringent situations, really, maybe financial issues, really, about meeting that demand, really, of buying even the ticket, really, she's not able to come, but actually sent her greeting to us, and she has been supporting me, doing science, really, involved traveling every time, leaving your wife at home, but for showing that cooperation and tolerance, really, I really appreciate her for that, and our children as well. Once again, let me just thank you all for this talk, and thank you even for the time. Thank you so much, John.
Any questions for Andrew? No, we'll move on to the next one.
Okay, thank you.
Okay, Gabriel, come on up and introduce Francesca.
Thank you. I'm thrilled to introduce Francesca Landis, Dr. Landis, who received the Science for Solutions Award. This award basically wrote itself with nominations from several people in this room. And you'll see that she demonstrates exactly what this award is about, which is she is committed to having science not just make a difference in journals, but also make a difference in communities. So without further ado, Francesca.
All right, good morning, everyone. Thank you so much for being here, and thank you, Gabe, for that kind introduction. Here, we'll jump back. It's really an honor to be awarded the 2019 Science for Solutions Award, and I really want to thank the nominating committee led by Gabe and the other recommenders in the room, my advisor, Lex Van-Geen, and Aubrey Miller as well here, for making this possible. And for those of you who are considering nominations or looking at awards in the future, you know, I do encourage you to put in those nominations. It's very, very, very helpful and encouraging for those of us who get them. So today I'd like to talk to you about the work that I've been doing throughout my doctoral research and kind of the current and future directions that I see for this, and focusing on identifying hotspots of lead contamination through collaborating with community members and a use of a field procedure to screen soil for lead. So I'll go over about why we care about lead, how lead can be found in soils and the heterogeneous nature, and this field kit, the field kit that I've developed, and then some applications that we've used, both in Peru with parents, in New York with community members, and looking at working with schools in Peru to implement this field kit, and how we can use that to raise awareness and reduce exposure to lead. So first of all, of course, it takes a village. So I wanted to thank everyone who's helped me and supported me in these projects. So my advisors and committee members, the nominating committee, also the AGU GeoHealth Committee for providing leadership opportunities for me and to grow. And of course, at Lamont, many of the scientists that I work with are collaborators in Peru, Dr. Johnny Ponce Canchihuaman, who leads a lot of the work that's ongoing, undergraduate students at Barnard College in Columbia, and the nonprofit in New York City, Neighbors Allied for Good Growth, that's been instrumental in helping us work with these community groups to implement the field kit. So moving on, I'm sure everyone has an association that lead is bad, it's toxic, it's a cumulative neurotoxin, and it's particularly harmful for children. So at these levels that we're normally seeing and that we're concerned about, we're looking at damage to the brain and nervous system and the impacts that can do on IQ and learning ability. Exposure can come from a variety of sources, including, of course, the water that you hear, but one of the things that's often overlooked is the exposure to soils, which really record our legacy of lead contamination. So lead binds and absorbs very readily to organic matter, to soils, and so throughout the past when we used leaded gasoline and leaded paint, that's been attached and absorbed to the top, to the soils. And young kids, I mentioned we're worried about them, we're more concerned about their exposure because they are engaged in hand-to-mouth behavior, so that exposure to soils and dust that we might not think about is really of concern there. And this impact is large enough that, you know, since we've phased out the lead in gasoline, so the impact for the decreases in IQ from lead exposure, that since we've phased out the lead in gasoline, there's an estimated $2 billion every year added in economic productivity from this regaining of IQ since we've removed that lead. So the idea, I mentioned that they work with Peru, so the idea for me originally was really, really motivated by the fact that many people did not have access to the same methods to test for their soils. So we might be able to send a sample to a lab, and in these small mining impacted communities in Peru, they did not have access to this. So the idea was how can we create a field procedure to screen for soils so that at least we can identify these high, medium, and low areas. So just showing you kind of briefly the steps to go through it. We want to sieve the soil, and then it's actually added to a glycine solution which simulates stomach acid. So the idea is once a child is exposed to soil or dust in the stomach in a high acidic environment, the lead can be released. And so we're mimicking the gastric extraction here, and then combining it with sodium rhodizonate, which forms a color precipitate with lead. So at the end, this is a procedure that students can do, community members can do, and the idea that this is publicly accessible. And then at the end, you see a color result, so low, kind of a yellow, orange color, and then the intensity of the purple precipitate, and the purple color gives you a range for how much lead you have in your soil, or how much bioavailable, how much lead will leach out of that soil. So we wanted to compare it, of course, to an approved bioaccessibility method. So here on this plot, what I'm showing is on the x-axis, the approved method, that's an EPA method based off a paper by Drexler and Bratton, the amount of lead that is extracted by this method compared to the amount of lead that is extracted by the field procedure. It does extract less since it relies on methods done in the field and not in an incubator in a lab, but it does so consistently over a range, and in a way the idea is that this is something that can be done without the lab. So we felt pretty comfortable with this, and then wanted to look at how the color results works, right? So here, high is everything that was in that dark purple in that first image. Medium is kind of a middle, lighter purple, or maybe a brown, gray. You're not quite sure if you're seeing the purple indicative of lead, and then low is everything where you're certain it's not. And I'm comparing it here to two US EPA, Environmental Protection Agency levels, the 400, which is assumed, or is the standard for residential soils where children play, bare soils, and 1200 for other residential areas. So those are mapped on there so that you can see that really, if we're getting a high hit, we can feel pretty confident we've got a large amount of hazardous amount of lead in there, and if we're low, it's doing pretty well as well. I mentioned it forms a color precipitate, so we can actually look at this level, look at these samples 24 hours later and see how much precipitate has settled out to the bottom. And I found that this actually helps identify even better the range of lead concentrations, and it pushes that low detection limit kind of down further, so when we can see that, feel confident that we either have high, medium, or very high levels of lead. So this is the field procedure, and I've been very lucky to have the opportunity to apply it in a few settings, and I'd like to walk you through the first one of those, which was using it in Peru. So over there in the top, your top left, I have a map of central Peru. And so there are a few towns here. Cerro de Pasco is an infamous mine. La Arroya is a smelter town. And then Lima and Callao are the ports. And so we've worked in these towns, but also several towns in the middle of them, where the main transport route from taking the mineral from the mine to the smelter, then down to the port for export, where those pass through. So first I'll be looking kind of right in the middle there between La Arroya and Lima. And we worked for these smaller communities, as you see here, and a map that we made by handheld XRF, so that's X-ray fluorescence. It's an instrument you can use in the field to quickly gain information about various elements, including lead. And the map on the right there is the map that we produced based on that XRF data, so where we found soils that were very high in lead, medium, and low. And again, this was actually a map that we posted in the communities to be able to share that information back. So a key point is to make sure that the local community is aware of the information, knows where to avoid spending time, make sure their children aren't playing in those soils, so that we can, so that their children are not exposed. The second step, so this is perhaps the more traditional route, if you will, of collecting and presenting soil samples, is that we worked with parents to collect soil samples with this field procedure. So we worked with them, trained them how to use the kit. The kit involved collecting the soil sample, sieving it, as well as then analyzing it with me, with the extract, and at the time we were using field test strips. One of the things I didn't mention as well, but we use cell phones to record the sample locations, and this has been really useful for us to both take a photo of the sample location, use the GPS to record the sample location, and then make maps, such as the one you see at the top, as well as use the cell phone during the kit analysis, so then you can take a photo of the final color. And we've learned to have it be done on a white background, things like that, to be able to then go back and look at our data. So we worked with these parents, and we were 25 parents. They all had young kids, and we wanted them to collect samples where their kids were playing. So I just put in an orange square in there, so I'll focus in on that area. So if we zoom in, This is the data for the area from our 2015 XRF survey that we took. And we were walking around publicly accessible areas where we could to measure the soil. And then these were the samples that came back from parents. And so I had these maps that I am showing total soil lead concentrations to be able to compare them. So everything in green is below 280 parts per million or milligrams per kilogram based on the Peruvian standard. So I've adapted that for this. And then everything in red is above that 1200, which is similar to the US standard there. And so the parents came back with a field kit. We noticed that there were some high samples. And mind you, if you notice, this is 2016. So we had presented these results already and kind of shared with them. And so we went back, right? We wanted to make sure that everything was right. So now the last one, I'm showing a complete map of the entire area. And so indeed, the parents had found a new hotspot. So using this community-engaged approach where the parents were collecting samples, really where of the most concern, right? They were collecting samples where the kids are playing. So where they knew exposure was occurring, and parents collecting these samples found a hotspot that we had missed. It turns out, as a lesson learned for environmental protection, I guess, is the area was built on top of mine tailings, and it seems to have been capped with a lower lead level on top, but there was new construction going on, and as they were digging out, they were getting into these contaminated soils that were essentially mine fill, or mine tailings that used to fill the narrow valleys, and that was the high exposure. So our next step is working, and this project has been going on since last year, again with our collaborators at the Center for Research in Environmental Health through a USAID peer grant, which is a fantastic program I also recommend you to look at. And we've been working with high school students, high school science classes, to test soil for lead with the field kit. So far we have data for, well, many more now, but for 2018 we had 124 students collecting samples in 3 different towns representing different contamination sources. And you'll see we can make these maps. So the top one is the soil XRF data, and then we're looking at the amount of lead that is extracted or extractable. In the bottom left corner there, and then the extract color. And you see really kind of the C shape towards the edge of the mine actually there showing up as the area of the highest lead contamination. And so I'm really interested looking forward how you can integrate similar activities into high school science classes or community organizations, both as an effective way to collect environmental data where areas that aren't being tested, but also to work from the education side of teaching students or having them work on a real-life, community-relevant project that's meaningful for them in their science class. We also, I briefly want to talk to you about the work we did in New York City. So this was through a collaboration, actually a series of projects that started with working at a farmer's market there in the bottom right, inviting parents to use the field kit to go home to test 7 samples in their backyards, come back, and we'll analyze them together. And I was starting to get really worrying levels of lead from these New York City backyards. So we then worked with students through Barnard College to systematically sample some neighborhoods in New York. So I'll start here with a map of public spaces. So this is northern Brooklyn, and this is a map of soil lead concentrations. Again, everything green and yellow is below 400 parts per million. Here, I'll open the second one there. And everything in red is above 1200. The one on the left actually shows you the soil samples from people's backyards. So these are homes, residents, people are playing in them, children are playing in them, people are growing vegetable gardens in them. It was really striking to see the difference between the lead concentrations in our backyards compared to the lead concentrations in public areas. and if we look at this as a box plot, we can confirm what we're seeing in the map of the much higher concentrations in these in these homes. And really, if we're thinking about exposure again, where are we testing? Are we testing where children are playing? Are we testing where people are exposed? And that's something that I think incorporating a field kit can be really powerful by working with communities. They know where they're exposed. They know where to test. And so future directions, looking forward, my advisor, Lex Van Heen, has worked more with high school and middle school science classes in New York City, and we're excited to kind of continue pushing that forward. We have the ongoing project in Peru with our collaborator and the USAID peer grant. I'm also interested in working more with community science organizations, both maybe with parents as well as with students. So BioBus is another group in New York working kind of as a extra science curriculum for students throughout New York City. And to that end, one of the questions throughout my PhD, and especially towards the end, that I was always getting was, well, how can I get this if I wanted to collect samples? And my answer had always been, well, you can collaborate with us, and we have some limited capability to make kits in our lab. And so looking forward, I'm starting a company to develop and optimize these field kits as well as produce and distribute them. So we're working with Columbia to look at an NIH STTR grant to improve the usability and production for this, as well as long-term thinking about if we're collecting this environmental health data, how do you make it useful for the most people? Can you provide a platform for people to opt in if they're willing, especially as well for public spaces, to share that data, and how can you aggregate that data so that people know where the hazards are so that they can avoid those places, take action to reduce their exposure and protect their children. So with that, I'd like to thank everyone again who's helping me through this project, and I'm open to taking any questions.
I have the first question. Do you have a good hypothesis for the backyard correlation? Is it lead paint, do you think, or something else?
So the question was about the correlation for the backyards. I think lead paint could be an important factor, but I also think we're looking at the age of soils. So these are small backyards with no alleyways and no access ways. New York City had a 1 million tree planting program. A lot of the atmospheric lead really was peaked in the 70s. And so the urban parks and urban street trees, they've also been redone and replanted and have had new soil brought in and new landscaping brought in. But yes, of course, they're much closer to a leaded paint source that's right immediately there. So I think they're probably both factors. Thank you. So we started, and the reason we actually started working in Greenpoint, in that area of northern Brooklyn, was based on blood lead data at the city level that was available kind of at neighborhood scales at the time. We have looked some based on census tract data that was available, and did not see a correlation. So some of the data that I didn't show then looked at the Upper West Side in Manhattan. I mean, we only had, I think, 15 homes in that yard, so that was towards the end, so our sample size is not representative, where they were still very high, so similarly elevated soil lead levels, but not on the blood lead. I think New York City is very difficult as well because of the elevation of the buildings, and so your number of children and children who have access to soil compared to, right, if you're in a 10-story building versus a 2-story brownstone, how you're comparing the number of children So if you're looking at a percentage of kids with an elevated blood lead, where most of them don't have access to a backyard compared to, my question there on the census tract data, I would really be interested in trying to work with pediatricians at a local level to try to get more paired data for blood lead and soil lead. As far as I know, the New York City Health Department currently, if they have an elevated lead in a child, we will go in and test for paint, but they won't go and test for soil. So my dream would be they would also test for soil so that that data set could be expanded.
I think this is a really nice opportunity to go to health departments and to expand their screening, which should be done on kids, right? And more robustly, most kids are not tested, unfortunately, especially in high-risk areas. And I think the importance of doing this kind of work and being able to show that the risks are high in these neighborhoods is more impetus for us to be doing better with the screening as a public health effort.
Yeah, that would be great.
Anybody else? Okay, well, thank you very much for attending. Thanks all the speakers.